Hey everyone, in this lecture we're going to be going over arrays. So arrays are useful because they let us hold many pieces of data and then we can access those pieces of data using a single variable. So let's create an integer array. New int 100. So this line of code creates an integer array, basically creates 100 blocks, or it reserves 100 blocks of memory. And then inside each of these blocks of memory, it just places the value 0. So now we can prove this by printing out the value myArray at 0. So this line of code, it goes inside of myArray, and then it fetches the 0th index. So whenever we're working with arrays, we always count starting with 0. So this is the first element right here we access by index 0. The second element we access by index 1. The third element right here we access by index 2, and so on. So now if we print this out, we'll get a value 0, which is what we would expect. Now suppose, this is pretty useless. We don't want an array that just has zeros. We actually want to be able to set our own values inside of an array. So suppose we wanted to, set some arbitrary numbers in here, like that. Okay, well then we can change the value inside of an array by doing the following. Oops. So what line 7 does is it goes inside of myArray. Then it goes to the 0th index. Okay, so now we're going to go to the 0th index right here. So it has a value of 0 originally. Then we set the value at index 0 to 20. So then that gets changed to that. Okay, cool. Similarly, we can do myArray at 1 is equal to 30, myArray at 2 is equal to, maybe we want 2 in this case, right? And so on and so forth. So now we can print out the 0th index, and we see that it has a value of 20 now. Okay, cool. Suppose now that we reserved only 5 blocks, or 4 blocks of memory. So we've already set the values for the first 3 blocks. What happens when we try to do this? Well, this is going to be fine. We reserved 4 blocks of memory. 1, 2, 3, 4. We get rid of this one. So we've reserved 4 blocks of memory. Each has a value 0 originally. Then the first block of memory, we give it a value 20, then 30 for the second block, then 2, and 4. And we can print out. And we'll get a value 4. Okay, cool. But now suppose we did this. Well, now what we're trying to do is we're trying to access the 4th index. But our maximum index is 3. Index 0, index 1, index 2, index 3. We haven't reserved any memory outside of here. So everything outside of here, we don't know what it is. So when we try to do this, our program is going to crash because we haven't actually reserved space for a 4th block of memory. So when we do this, we're going to get this exception right here. Java lang array index out of bounds exception, and it'll tell us, if we click here, it'll tell us what line is causing the exception. So in this case, it was pretty obvious that we'd only reserved this many blocks of memory, and then we were trying to set a new value. But oftentimes, that's a little harder to see, especially when you're working with for loops. So it's just something to keep in mind, that you always need to stay below the maximum size. In other languages like C or C++, your program often actually doesn't crash when you try to access indices outside of your original, outside of the blocks you've actually reserved originally. So now let's get rid of some of these lines. Suppose we wanted to print out every single value inside of the array, but we didn't want to create a very long print statement, right? Like we could do myArray at 0 plus comma, and then we can do myArray at 1, and so on, right? And I mean, that's reasonable when you have maybe 4 elements, but suppose 4 elements, but then suppose you have 400 elements. It would take forever to write them all out. So we use something called a for loop. A for loop, what it does is it's a loop that starts at a certain value. The loop keeps going until this second condition resolves to false. And then on each iteration of the loop, we add 1 to I. So let me just show you what this does, and then we'll go through it step by step. So indeed, yes, we do print out every value inside of our array. So what this does is it creates a variable of type int. It's called I, and we set its value equal to 0. Then every time we loop, we make sure that I is less than the length of our array. Well, the length of our array is 4 because we reserved 4 blocks of memory. So if this condition is true, if I is less than the length of the array, then we do whatever is inside of our for loop. So what we're doing inside of our for loop is we're printing out the ith index in our array. So I starts at 0, then on the second iteration of our loop, I is going to go to 1, then 2, then 3, and then 4. And that's just going to let us access each of these indices and print out the value stored there. Now, at the end of each loop, we add 1 to I. So I starts at 0, then we add 1 to I, so now I is 1. Is 1 less than the length of our array? Yes, then we do whatever is inside of here. And is 2 less than the length of our array, then we do whatever is inside of here, and so on, until we reach the end of our for loop and we printed out every value. Now, suppose we wanted to make a simple program that would sum up the values inside of our array. So let's just do this in our heads really quickly. Suppose we wanted to add up all of these values. We would do 20 plus 30, that's 50. 52 plus 4 is 56. So we know that our total sum is going to be 56. So to do this, let's create a variable called sum. And then all we're going to do is we're just going to add, this is the same thing as doing sum is equal to sum plus array and I. So you take the previous value of sum and then you add on the next value inside of your array. So let's just print this out. It's pretty straightforward. We're just going to get 56. Okay, cool. Let's go over some useful methods that we can call on arrays. Most programmers at least don't actually make good use of the arrays class. So this class has a lot of useful methods that let us sort arrays, that let us find values inside of our arrays, that let us convert arrays to strings. So let's just sort our array. So if we sort my array, and then we print out, let's make another for loop here. Well, then we're going to print out the array sorted. I can't remember if it's descending or ascending order. In ascending order. So what that means is it's going to put 2 first, then it's going to do 4, then 20, and then 30. And that's exactly what we get. So this is just a really useful method whenever you have an array and you want to sort it, but you don't want to write your own, maybe like merge sort or binary sort or whatever kind of algorithm. Now, suppose we wanted to work with an integer, with a string array, I should say. String names, new string, 20. So what this does is it reserves 20 blocks of memory, and inside each of those blocks of memory, we can put a string. So as before, we can go through manually, and we could fill it out. 1 is equal to Willie, and so on and so forth. But this syntax, it's kind of redundant, because what we're doing is each time we're going inside of our names array, and then we're fetching the index, and then we're incrementing the index ourselves, and then we're setting the value. So we can also work with an alternative syntax in Java that lets us just define each value inside of our array like this. Sam, Frodo, Mary. So what this does, this is the same thing as creating an array that holds 1, 2, 3, 4, 5 blocks of memory, and then setting the value inside each of those indices to maybe Joey, Willie, Sam, and so on. But it's nicer to look at, and it's a little more convenient to write because we don't actually have to know the size of our array. We can just keep typing out elements. We can print out these names using another for loop. print line names at I. And so we can print it out, and we'll get Joey, Willie, Sam, Fardo, Mary. Cool. Now, finally, suppose there's another alternative syntax for for loops called for each loop. So what this thing does is it does the same thing as this for loop right here, except it kind of covers up these this I variable for us. So it takes care of incrementing our loop and making sure our loop stays within conditions, and it just gives us this value right here. So to show you what I mean, it's the same thing as doing this. Maybe I should call this name is I. So these are doing the same thing, because what you can see here is we're just fetching the ith index in names and returning a name variable right here. It's the same thing right here. It's just taking care of all of these little details for us and giving us the name. And to prove that this works, let's just print it out. Let me comment out this print statement right here. Print line. And boom. So these are the exact same things. This syntax is generally nicer. It looks a little better. It takes care of incrementing and all of this other kind of like low-level stuff. So if you can, this syntax is actually preferred. Or I mean, it's not preferred, but it'll make your code look a little better. And that wraps up this video, guys. I'll see you in the next lecture.